So this will be the first video in a series on polynomials and exponents, okay? So we'll start by just kind of looking generally at exponential notation, then we'll move into some of the exponent rules and then polynomials as a whole, okay? So let's get started. Hopefully you have at least a general understanding of exponential notation, but if not, I'll go ahead and just kind of briefly start there. So exponential notation . In short, it's the use of exponents. But more importantly, exponents are shorthand for repeated multiplication. So for example, if I have 2 times 2 times 2 times 2, we can see that I'm multiplying 2 by itself repeatedly. So this is repeated multiplication. So what we do is we take the number that we're multiplying over and over, the 2, and then in the upper right-hand corner, we put a little number that represents the number of times 2 was multiplied by itself. So 2 times 2 times 2 times 2 is the same as 2 to the 4th power. So in this particular case, 2 is what we call the base, or the number being multiplied repeatedly. And the 4 is the exponent. And this represents the number of times the base is multiplied. All right, so what I want to do now is just look at a few examples. We're going to evaluate. So in math, when you see the word evaluate, always think like work it out. So we're going to go ahead and take something that's written in exponential notation. We're going to expand it out and we're going to figure out what that product would equal. All right, so let's say we go back to this 2 to the 4th. So I know the base is 2, that's the number being multiplied. We already know that we're going to multiply 2 by itself 4 times. But then what does 2 to the 4th equal? Well, you could certainly use a calculator to assist you on this, or you could multiply it in your hand. I know 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So 2 to the 4th evaluated out would just be 16. Next up, let's say we have 5 to the 3rd. Well, that would be the same as 5 times 5 times 5. All right, so I've multiplied 5 by itself repeatedly, 3 times in fact, and 5 times 5 is 25. 25 times 5 is 125. What if I had 10 to the 2nd power? Well, that's just 10 times itself twice. And hopefully we know that 10 times 10 is 100. Let's change that. We'll do to the 5th here. So let's say we have 7 to the 5th. So I have 7 times itself. Oops. 5 times. So 7 times 7 times 7 times 7 times 7. Now that one's going to be a little bit harder to do in your head. So you could just use a calculator and you should get 16,807. So one thing that I really want to make clear, when you're dealing with exponential notation, for example, if we go back to this original example of 2 to the 4, this does not equal 2 times 4. It equals 2 times itself 4 times, okay? So be on the lookout for that. Now, what if I changed it and I gave you something that was written out as repeated multiplication, but I wanted you to write it in exponential notation? So for example, let's say I have 8 times 8 times 8 times 8 times 8 times 8. Well, I can see that the base here is 8. 8 is what is being multiplied repeatedly. And then how many times did I multiply 8 by itself? Well, 1, 2, 3, 4, 5, 6. So this is 8 to the 6th power. What if I had 11 times 11 times 11 times 11 times 3 times 3 times 3 times 5 times 5? So in this particular case, hopefully it's easy to see that you have 1, 2, 3 bases, okay? So if I look at just the 11s, my base of 11, all right, Well, how many times did I multiply 11 by itself? I multiplied it 1, 2, 3, 4 times. Moving to the next base of 3, well, I multiplied 3 by itself 1, 2, 3 times. And then my final base is 5, and I multiplied 5 by itself twice. Okay, so you need to be able to take something that's in exponential notation, understand how it expands out and what it would evaluate to, but you also need to be able to take this idea of repeated multiplication and write it in exponential notation. Also, don't ever forget this fact. You're not taking the base and multiplying it by the exponent. You're taking the base and multiplying it by itself as many times as the exponent tells you to. All right, now another really important thing that's going to come up is negative bases. And quite honestly, at this point, everything so far should be something you've seen, including this idea of a negative base, okay? So hopefully this is review. I'm going to kind of treat it as such, and then as we move through, we'll get to hopefully the newer stuff. But this is one area that students struggle with a lot. So even if you've seen it before, watch this part of the video. It's worth seeing multiple times. So there are basically two cases. The first case, the negative is inside parentheses. So you'd have something like negative a to the n power. Here, the way you determine if your product is positive or negative all depends on n. If n is even, the final product is positive. If n is odd, the final product is negative. Okay, so let's look at a few examples of this. So we're going to use a base of -2 because 2 is just kind of easy to work with. So let's say we have -2 squared. Well, everything inside parentheses is going to get applied to itself. So the exponent gets applied to the entire -2. So that means the -2 parentheses and all repeats. So I get -2 times itself twice. And you have to go back to multiplying signed numbers. When you multiply two negative numbers, the product is positive. So here I would just get 4. Well, if I did -2 to the third power, again, that with the parentheses, that negative and the 2, they get held together forever. So that exponent is going to be applied to both the negative and the 2. So when I rewrite this, I'm going to rewrite it parentheses and all. So -2 gets multiplied by itself 3 times. Well, 2 times 2 is 4. 4 times 2 is 8. But let's look at the signs. If you go back to multiplying signed numbers, 2 negatives make a positive and a negative make a negative. So right here, the first 2 negatives become positive. But then I've got a positive times a negative, which makes my final product negative. So now let's look at -2 to the 4th power. Again, the negative and the 2 are bound together by the parentheses, so the parentheses and all get multiplied out. Well, 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So we know we're going to be dealing with 16, but we have to determine if it's going to be positive or negative. Well, again, going back to our rules for multiplication, 2 negatives make a positive. So basically, these -2's pair up. Each pair of 2 becomes positive. That means your final product is going to be positive. Let's look at one last example. So -2 to the 5th. The parentheses mean the negative and the 2 are bound together, so everything gets multiplied out. And in this case, 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32, but are we dealing with a positive or a negative? Well, the first 2 pairs become positive. So we have 2 pairs of 2, each becomes positive, but then I've got this negative over here. So the the first two sets of positive, when I multiply those out, I get a positive, and then I get a positive times a negative. Either way you slice it, you're going to end up with negative 32. So really, this rule here, it all just comes down to, is that exponent even or odd? Is that negative going to show up an even number of times, or is that negative going to show up an odd number of times? If the negative shows up an even number of times by the multiplication rules, you'll end up with a positive product. If the negative shows up an odd number of times by the multiplication rules, you'll end up with a negative product. So that's the first case. The second case is when the negative is not in parentheses. So you would have something like negative a to the n. Here, this is always negative. And here's why. Negative a to the n. The issue here is that the negative a is not in parentheses. In the first case, the negative a was in parentheses. That meant the negative and the a were bound together. And just keep in mind, negative a is really just -1 times positive a. So when I put that in parentheses, that exponent gets applied to both pieces. But if I have negative a like this, and I write it as -1 times a to the n, the a gets the exponent, but the -1 does not, okay? So basically right here, this is like -1 times a to the n. So when I have just a to the n, it's always going to be positive, and then I'm always going to have a positive times a negative, okay? So this is always negative. Now let's look at some examples. -2 squared. This is like -1 times 2 squared. -1 times 4, -4. -2 to the third. This is like -1 times 2 to the third, or -1 times 8, which is -8. -2 to the fourth, -1 times 2 to the fourth. That's like -1 times 16, or -16. So in the second case, it doesn't matter what the exponent is. It doesn't matter if the exponent's even or odd. It's this idea right here that I've circled in red. Negative a to the n without parentheses, the negative and the a really separate into -1 times a to the n. A to the n is always positive. Then you take that positive a to the n, you multiply it by -1, your product is always negative. Let's look at some examples. And we'll just do a few of these and then we'll kind of move on. So let's say I have -5 squared. Well, in this case, I do have parentheses. So this is like -5 times -5. Those parentheses, they bind the negative and the 5 together. You can't separate them. So this would become +25. But what if I had -5 to the third? Well, same deal. That negative binds the parentheses bind the negative and the 5 together. So I would get -5 times -5 times -5. 5 times 5 is 25. 25 times 5 is 125, but is it positive or negative? Well, you count the number of negatives. I've got 3 negatives here, all right? With an odd number of negatives, you're always going to pair up 2 negatives to make a positive, but there'll always be 1 left over. So this is negative. Now let's look at it like this. What if I have -5 squared where the negative is not in parentheses? Remember, this translates to -1 times 5 squared. Without parentheses around the negative and the 5, we separate them, all right? So this really becomes -1 times 25, or -25. -5 to the third is really -1 times 5 to the third. So it's -1 times 125, or -125. What if I had -1 to the 8th power? Now, hopefully you remember that anytime you have a base of 1 raised to some exponent, the product's always going to be 1, because 1 times itself repeatedly. No matter how many times you multiply 1 by itself, you're always going to get just 1. So in this particular case, we're going to get 1, but is it going to be positive or is it going to be negative? Well, since the negative is in parentheses, we look at the exponent. The exponent's 8, that's even. That means all of those negatives would get combined pair by pair to become positive. So this is going to be positive 1. What if I had -1 in parentheses to the negative 11th power, to the negative 11th power, just to the 11th power, sorry. All right. So again, it doesn't matter how many times I multiply 1 by itself, I'm always going to get 1. But now we have to ask ourselves, is it positive or is it negative? We look at the exponent. The exponent is odd. That means all of those negatives right here are going to pair up with 1 left over. That 1 left over negative makes the whole product negative. What if I have -1 to the 15th power? No parentheses here. So this is like -1 times 1 to the 15th. Well, 1 to the 15th is just 1. So I get -1 times 1 or -1. Okay. This is a little bit trippy for students. Just always go back to this idea of 2 cases. Your negative base is either in parentheses or it's not. If your negative is in parentheses, you look to the exponent. Even exponent, positive product. Odd exponent, negative product. The other case is where your negative isn't in parentheses at all. And if that's the case, your product is always going to be negative. Okay? So one other thing I want to look at is towards the end of this example here, we looked at what happens when the base is 1. So when your base is 1, whether it's positive or negative, your product is always going to be 1. Sorry, I keep getting this line more and more crooked. All right. So when your base is 1, that just means your product is going to be 1, positive or negative, depending on the situation. But what if the exponent is 1? So 1 as an exponent. Well, if I had something like 10 to the 3rd, that equals 1,000. And then I'd have 10 to the 2nd, that equals 100. And then I have 10 to the 1st. Well, what does that mean? That just means my final answer is just plain old 10. That's just 10 multiplied by itself just that one time. So it's kind of weird because you're not actually multiplying 10 by 10. It's just 10 is there all alone. Okay, so be really careful when your exponent is 1. It doesn't mean you're multiplying 10 by itself a number of times. It just means 10 shows up once. So if I had something like 5 to the 1st, that just equals 5. -6 to the 1st, well, this is -6, okay? -8 to the 1st, -8. 12 to the 1st, 12. X to the 1st, just plain old X. So what ends up happening in math is we don't actually show the exponent of 1. So an exponent of 1 is kind of always assumed. I have this one number all by itself. It's not being multiplied by anything really. Okay, so exponents of 1 just mean you get what you've got. Okay, now let's look a little bit more at some exponents when we deal with variables. Okay, so if I have x to the 2nd power, just always remember what that means in the repeated multiplication where things are expanded out. So x to the 2nd would just be x times x. X to the 5th is x times itself 5 times. Okay, if I had something like x to the 3rd times y, that's x times itself 3 times y. I could have x to the 2nd times y to the 4th. That's x times y times y times y times y. It's important to understand what these variables raised to powers mean when you multiply or divide things out. So for example, x to the 5th over y squared is just x times x times x times x times x all over y times y. Okay, so just don't forget, if we go all the way back to that first slide, exponential notation is the use of exponents, but what that really means is it's just a way of writing repeated multiplication in shorthand. Okay, definitely understand how that works with exponents, because in the next video that we're going to do, we're going to look at exponent rules or laws of exponents. And in those particular cases, it's really good to have a strong understanding of what exponents mean. Okay, now last up for this video, we're going to evaluate. Okay, so when we evaluate, let's say we had something like 3x to the 5th for x equals 2. Okay, well, Anytime you see the word evaluate, it either means simplify completely, or if you're dealing with variables, it means plug a number in for the variable and then simplify. So we want to think of this as 3 times x, which is 2 to the 5th power. Now, this exponent of 5 is only applied to the x, okay? So I want you to understand that 3x, 3x to the 5th does not equal 3x to the 5th, okay? In this first example that we have right here, the 3x is in parentheses. That parentheses is binding the 3 and the x together, so that would mean the 3 and the x are raised to the 5th power. Without that set of parentheses, it is quite literally 3 times x to the 5th separately, okay? And that's what's happening in this example that we have right here. We have 3 times and then separately x to the 5th. Well, x is 2, so we would need to figure out what 2 to the 5th is. So it would be very appropriate to use your calculator here, just show your steps. I happen to know that 2 to the 5th is 32, and then 3 times 32 is 96. So that would be evaluating where you do have exponents, okay? What if I had something like this, negative 7xy to the 3rd, and we're going to evaluate for x is 5 and y is negative 1, okay? Now, the negative 7 and the x do not get the exponent of 3. I want you to see this very clearly. We have a negative 7, which is being multiplied by an x, which is then being multiplied by y to the 3rd. The exponent of 3 only goes to the y. So I'm going to evaluate. I get negative 7 times x, which is 5, times negative 1 to the 3rd power. So I'm going to go ahead and take care of the negative 7 times 5 and the negative 1 to the 3rd power kind of in the same step. So negative 7 times 5 is negative 35. And then negative 1 to the 3rd power, we have to go back to our exponent rules. We had negative 1 to the 3rd power in parentheses, so we're dealing with this case right here, okay? Our exponent was odd, so that means our final product for that piece is going to be negative, okay? So I have negative 1 to the 3rd power. It's going to be 1, and because my exponent is odd, it's going to be a negative. So then finally, I get negative 35 times negative 1 is positive 35. Now, just to make sure everybody's clear, negative 1 to the 3rd is negative 1 times negative 1 times negative 1, which equals negative 1, okay? Be especially careful when those bases are negative. It's not really a hard concept. There's not a lot of work involved. It's just really understanding how those exponents and those bases work, okay? Let's look at a couple more. So let's say we have negative 12 x squared y to the 4th for x is negative 1 and y is negative 2. So to be clear, 12 is just 12 by itself, so it would technically be like 12 to the 1st power. You have x squared, the exponent of 2 only applies to the x. Y to the 4th, the exponent of 4 only applies to the y. So I'm going to multiply this out. I get negative 2 times x, which is negative 1 squared, times y, which is negative 2 to the 4th. So let's do a little side work here for negative 1 squared and negative 2 to the 4th. So negative 1 squared, I get negative 1 times itself twice. 2 negatives make a positive, so this is going to be negative 12 times positive 1. Now, negative 2 to the 4th is going to be negative 2 times itself 4 times. Okay, so we've got 2 pairs of negatives that are going to become positive, so everything's going to be positive here, and 2 to the 4th is 16. So what I really have is negative 12 times 1 times 16, or negative 192. Be especially careful with those negatives, okay? Can't say it enough. Now let's look at one more like this. And then I do think in this video, I'll go ahead and show you what happens when you have a 0 exponent. And then it'll really come up more in the next video, but I just want to give you like a gentle introduction to it right now. All right, so let's say I have x to the 3rd times y to the 5th. And we're going to evaluate this for x is -5 and y is 3. Okay, so I get -5, which is x to the third power, times 3 to the fifth, where 3 is y. Well, -5 to the third power is -5 times -5 times -5. My exponent here is odd. That means my final product is going to be negative, and it's going to be -125. Okay. Now 3 to the fifth, my base is positive, so I don't have to worry about any of the sign rules. And 3 to the fifth just so happens to be 243. So now I want to multiply those out. -125 times 243 is -30,375. And there you have it. Okay, so again, it all kind of comes back to this understanding of negative bases. So when you have a base that's negative, it's either in parentheses or it isn't. Okay, and one thing I do want to be clear is in an example like this, let me do it in blue so we can kind of see. If I have x to the third and I want to evaluate for x is -2, we evaluate using parentheses. So this would be -2 in parentheses to the third, or -8. Okay, just be really careful. So going back to this screen right here, when you're evaluating with variables, those parentheses are kind of assumed. Okay, so anyway, negative bases, you either have parentheses or you don't. If you have parentheses, it all comes down to whether or not your exponent is even or odd. Without parentheses, it's always negative. Okay, so we did lots of examples. We looked at exponents where the base was 1, or not exponents. We looked at examples where the base is 1, examples where the exponent was 1. And then we looked at just some variable examples and evaluating. Okay, so this is a very, very quick video compared to some of the ones I've done in the past. Pretty much everything in this video should be reviewed. It should be something you've seen before. It should be something you already know how to do. But I wanted to do this reminder before we get into the next videos where things maybe are brand new and things that you don't necessarily know. Okay, so even if you feel sort of comfortable with this video, just go through the whole thing just to make sure you know what I'm talking about, especially those situations where the base is negative. Make sure you understand those rules, because that negative base thing can show up really anytime. Okay, so next up, we'll start talking about some of the laws of exponents. All right, so best of luck.